We're good. I think Pat was looking for clipboard pens.
Clipboard pen. I am on it. Oh, here's one of them. I think they go in the little side pocket.
Okay. Thank you.
Yeah, right. So we're starting blue sheets around.
And then we have a clicker. You want to do this one? You want me to?
All right.
Hello. We're going to get started. Welcome to Chicago and Detnet. The agenda and slides are in the usual spot. Everything should be posted. We're actually running from what was posted, so if it's wrong there, it's wrong here. We do have our usual note well. It's still Monday, so if you're not familiar with this, please look at it. Basically says that everything that you say here is part of our process. If you're interested in the details, there's off the IETF webpage, you'll find something that talks about the note well and the whole IETF IPR requirements. If you're new to the IETF, please take a look. We are streaming both audio and video with Meet Echo. There's a pink box when you present. Try to stay in it. That can be hard for some of us, and me myself notably. Never like staying in the box, right? We do joint minute taking. We use Etherpad. It's off the tools page. Actually, that link's a little hard to get to, but if you go to the working group tools page and click on, is it agenda? No, minutes, you'll see there's an Etherpad link. And please feel free to contribute, even if it's just looking at what is written and correcting something, adding one sentence, adding one word, it's all helpful. So the more people participating, the better quality minutes that we get and the faster they get out. We are using Jabber. I'm on the Jabber room. If anyone else wants to join, that's great as well. And we do have blue sheets going around. That captures who's here, which can be useful at times. More importantly, it makes sure that we get a room that's large enough to house everyone who comes the next time around. Our agenda is unmodified from what's published. We always like to remind people that having discussions on the mail list is really good, particularly on working group documents. This is actually has come up in other working groups, and has even come up in this working group where there are folks who know that there's a discussion going on an individual document and they would like to participate in that. And it's okay for authors who are working on collaborating on a document before it's a working group document have private conversations. Having it public is great, but once a document is a working group document, it's really important that even the authors use the list to make sure that everyone sees what changes are going on, what discussions are going on, and sometimes one that helps build consensus so that when the authors think a document's done, everyone else agrees. It's also useful because we end up getting different perspectives and hopefully get a better result. We have an IPR process that we follow in this working group that some other groups in the routing area follow. Basically, we ask for a statement on what IPR is known and that you're following the IETF rules in disclosure. And we ask that at working group adoption and at last call. So where are we on documents? we have the architecture document that has been updated, and there's a question of how close are we on that? And because we'd really like to sort of wrap it up and publish it so that we can move on and focus on other work in the group. There's been a little bit of a recent discussion on taking some text from other documents and moving them over. And if I remember correctly, we don't have the architecture. Document on being presented, right, Norm? You're not presenting. Okay. So I'd love to put the document authors on the spot and ask them what they think is necessary to bring this, to wrap the document up. Would you care to say anything, Norm or Pascal? I don't know if Pascal's here. And yes, they didn't know this question was coming, so I'm putting them on the spot.
Norm Finn, Huawei. I thought it was pretty good, but I had a hand in writing it. So if other people are satisfied, I'm tickled to death.
Yeah, we're waiting for Pascal to come up.
Pascal Cisco. Well, we've just provided some new text, which was effectively taken from another document since we discussed we would do that the last IETF. It's a matter of reviews now. If we don't get more feedback, what can we do? We're happy mostly with the content. We can do a pass of feedback.
You had
some suggestions that we could not include due to time constraints, so we get that to do as well. You said we should synchronize with the design team documents on some aspect, and you gave us some sections. It's just like putting it at the right place, the right way. We just did not have time. But
Okay.
that has to happen. Matter of back from the group.
So you're saying you're going to take another round, a bit of changes, issue another version. Do you think you have everything you need to issue that version, or do you need input from others?
You know, the problem is, from our perspective, we're happy. Norm is happy, I'm happy, and now we get channels, and we're all happy. Now, if the rest of the group is happy, that's what we don't know. But yes, we feel we have a consistent story.
Okay.
No, it does not reflect very much what the design team data plane document says. And then there's a little bit of consistency to be found there as well.
Is there a plan to synchronize with that? Do you want to set up a time to talk with other authors? I'm trying to get to how do we close this document out?
Well, kind of, how can we be sure that we're correct if the data plane is not published? So basically, we asked you also if there was a plan to publish a new data plane document soon, and if there are some changes which impact us, but you said in the maintenance, right? I'm just going, it was kind of stable, this piece that you want us to take. If you as design team data plane, are you happy that what we import is stable, then we're stable.
Okay. I think it would be good to have maybe an offline discussion with the chairs as well as the lead for the design team. Make sure we're all on the same page. Try to do that today, maybe. All right. So that would be really good to wrap up. Now we have some other working group documents. These documents are not necessarily core deliverables, but they're documents that are pretty well baked. What do we do with these? And we're asking for feedback from the working group. Do we want to just hold these off to the side? Do we want to wrap them up, take one last spin of pulling out anything that needs to be reorganized? Is it time to last call them? Are there opinions?
Ethan Grossman, Dolby. As far as I know, regarding the use cases draft, it's pretty mature, and I think that it's ready for working group last call.
The data plane alternatives. So that basically misses the conclusion that we had. So that should be added and it's good to go.
Okay.
Pascal again, I think the problem statement is good to go. We didn't get any comment asking us to change anything, and it was the basis long ago for the rest of the work. The question is more like, what do you chairs want to do with this document? Is it something that you want to leave as is? Do you want to publish it?
I guess from my personal standpoint, if it's done, I prefer that we move it on, publish it, and not leave it hanging out there. But I say that with the assumption that it's not going to take a lot of resources to finalize. So if we last call it and find we have to do major revisions, I would be less excited about spending a lot of the working group energy on a problem statement, because we know what the problem is. But if it's just we last call and we have agreement on it, if we have last call and we have agreement on it, yeah, sure, let's publish it.
Yep.
I didn't know if you were standing up too.
No, I'm standing up because I can legally.
Okay. Okay, so I think we got all that. Folks, by the way, please participate on Etherpad and capture as we go along. I think we've covered that slide.
Yep.
So in terms of our charter deliverables and milestones, where are we? We have the architecture. We've already covered that one. We have the data plane definition. That's a subject, big part of our discussion today. We have a flow information model as identified, and we have a draft that's a proposal on that, and also on the agenda. What we haven't seen yet are any proposed Yang models for control of our data plane. Well, it sort of makes sense because we're still in the process of defining what the data plane is and cleaning up or coming up with an information model. So it's understandable that's been blocked. It's unfortunate. We'd like to be a little bit farther ahead, but we've still been making good progress. There was some discussion at the last meeting about a service model document, and it looked like that had some good text. The way I read it is that document is sort of the content of that is being distributed across data plane documents, architecture documents, and information model. But that's sort of where I see that going. If the authors feel differently, now would be a good time to mention that. I see some nodding agreement, so that's good. With that, that's the end of the intro slides. Questions? Comments? Then we'll move on. Yoni, I think you're up. It says the battery is going, so it might work for a little while. I won't stop this.
All right, so I hope my voice carries. I got a cold last week, so yeah. So this is about the Detnet data plane and the document that design team has been working on furiously past few months. I hope that someone actually read it. So what we are going to go through today is about the generic update, the kind of solution, the solution basis what we had. Couple of the hard-cut/open issues and the next steps. So the glorious design team. So the members with the varying participation. Here some more, some less. And that's it. And so we have a mailing list. You can go and read it. It's not awfully much used, but it's there. And then we had a weekly design team calls, basically where most of the work was done. So we circulated a bunch of slides around. I tried to summarize everything that we discussed on the small memos that I sent out to the design team mailing list, so you can go and grab those. It also includes the kind of site material what we had, so the presentation and stuff. So everything should be documented. So this first incarnation of the data plane document, it covers the two use cases taken from the, so these pictures are a bit modified versions of what we have in the design data plane alternatives document. So the cases 1 and 2, so basically the interconnect and the end-to-end Detnet service model. So, and these were the cases that we agreed last time that we will spend our time on now. And about the solution basics, so it shows that we leverage the multi-second pseudo wires. So somehow seem to be the closest fit. And even if the most of our discussion has been going around on the MPLS-based PSN, we also have kind of considered that the IP-based PSN should be is also covered. Not that we just didn't spend too much time on it, but I don't see any issue about that because it's more or less like plug-in. We had one design team member who was very persistent about that we shouldn't be doing anything that would harm the existing control planes. And I believe that that's still the case. So what we have should be, with the minor modifications, pluggable into LDP, RSVP, segment routing, and then centralized controller model, so the guidebox style. So small updates are inevitable, so those will be done along the path when we get into the actual control plane. One of the kind of principles what we had was like try to maximize the reuse of the existing work, code base, hardware, whatever we have, and only extend where it really is needed to make the meet the use cases and also make the solution to work. So no new functional others. We need to have one. Otherwise, we just need to kind of, if we can get this by a different configuration of boxes or slight tweak on somewhere, we go for that. So the minor functions at the body of the work that we used, spend our time on was like mapping the what we have in the architecture document, the Detnet edge node, into a Detnet aware multi-second pseudo wire GPE, what we call then the .PE. And also the Detnet relay node, this is now the multi-second pseudo wire SPE, so .PE, what we call in the document. And great bulk of the work was spent on the flow identification, so that you had the one compound Detnet flow, which then might be split and merged in multiple ways in a network. And you want to know that which of the packets belong to which actual original Detnet flow. So for that purpose, we introduced a flow identification, so flow ID, which is now part of our pseudo-wire header. And related to above, so the most of our time was spent on the how to implement one of the particular feature of the Detnet packet replication elimination, how to do that with the reusing pseudo-wires. And as a result of that, you need the flow identification, and you also need to have the pseudo-wire control word sequence numbers around. So everybody wants to see how this looks on wire. So the kind of standard pseudo-wire stack, and this is what we have. So basically the same, but on this encapsulation layer of the pseudo-wires, we have the flow ID in there. And the multiplexer, we call it pseudo, so we have this multiplexer pseudo-wire label there. And this part of the encapsulation is always the same, independent whether you have the MPLS or IP PSN. All right. Then we have the slightly confusing terminology in our spec. It's called what we call the topology or overlay label, or L label, how we call it. And one of its uses is that we can selectively kind of build different overlays over the same network topology what we have, saying like a certain node can, or certain flows, it can be like act as a relay node that participates on the replication and elimination. For certain flows, you just bypass that node so it looks like a P node. So that's the use for that one. Just a part of the label stack, so what we just gave it a specific name for illustration purposes. Okay. So I'm going deeper in the packet format and so on. So we have exactly the same pseudo-wire control word what we have for the Ethernet over MPLS. So the discussion what we have there still, it is there, it's like is 16 bits enough. So we concluded that for the kind of easiness and the kind of backward compatibility with some of the existing solutions out there outside IETF space, it would be useful to stick with the 16-bit sequence number. Then we have the, as I said, the pseudo-wire encapsulation here also carries the flow ID. So the current version of the flow ID is 24 bits. Okay, so 16 million flows we can identify. And then we have like currently we also are able to identify like whether the flow came from the east side or the west side to a box. So if you think about the ring infrastructure, so you can think this direction bit as part of the flow identification bit, making it a 25 bit. So this allows you to make a different rule whether you, depending if you want to drop a packet, whether it came from the other side of the ring or so. That discussion is still a bit not entirely finished.
Are you, can you go back a slide? Do you mind questions now, or do you want them at the end?
At the end.
Okay.
So flow identification. So the so it's a part of the Detnet flow processing. So there's actually two parts of it. So one that happens at the forwarding queuing level. So you don't want to look deep in a packet to understand what flow is. So just for queuing and forwarding, you need to kind of encode the kind of behavior into your labels and TC bits. So if you have a certain resource reservation, your FEC and stuff need to kind of identify that. And also the flow identification is a kind of integral part of the flow processing when you want to do the replication elimination of the packets. And in that case, you already had kind of got your packet all the way up to your pseudo-wire processing, so you're not looking into labels and stuff anymore. So you're looking more deep in the packet. And there you combine the flow ID and the sequence number. So you basically identify the flow based on the flow ID number, and then you have the sequence number associated for it. And based on that, you can see however you implement your history buffer, you can look it up whether you have seen this packet or not. And then what comes on the replication part, so technically it's basically a replication of the existing 1+1 protection scheme. Okay. So more about the flow identification. So just as an example, so we have a same Detnet flow, but different packets in the flow. So we have whatever label stack we have, whatever pseudo wires we have, but the flow ID is identified, okay, within this network admin domain, where these flow IDs are unique, you know that this is the same flow, but they are not the same packet because the sequence numbers are different. and you have the same Detnet flow and two duplicates of the same packet, then you have the flow IDs equal and the sequence numbers are also equal.
So I guess we're having a crosstalk issue with the next room.
Yeah.
So if you just
Should we shout louder?
yes, we'll see who talks over each other. So just lean in a little.
I will. Okay. All right. So far so good. Then the current draft, it has a bunch of text about describing the inner functions of the PE node. So our .pe and the .both and .pe. So there's a couple of things that you need to kind of describe what goes in there. So basically, the major bulk of the description goes along that, okay, we have a function in there that actually understands to do the flow merging and the elimination of duplicates. And also, we still have a bit of not completed text about how that actually affects your LFIP configuration and so on. And okay. For the actual TPE node, we also have a note there that if you have a such NSP that is, for example, CB capable, so .1 CB capable, you could actually do all the replication and elimination that NSP function. In that case, none of these things that we've been defining for the Detnet pseudo wires, they are not needed because they wouldn't see any difference. This is just a fact. So if you're able to do that in that way, you're free to do that. This spec is not going to mandate that. So don't be afraid of it. So the interesting node is the one that is in the middle of the network, not on the edge of the network, but in the middle of the network, and which is able to do also the, which doesn't originate the flows or terminate the Detnet flows, but still participates to switching and relaying, also does the replication and elimination based on the configuration that you have given into that box. And also I have an example like what I said earlier, that with the overlays, that sometimes the same node can be a PE SPE node for some flows, but for some flows it's just a P node. And this magnificent picture is about that. So for the blue traffic, based on how it's label stack is built and also how the LFIP is configured, these packets just flow through this .pe node. So for the blue traffic, it's acting as just a P node. For the red traffic, based on the LFIP configuration and the new action what we will have for the Detnet traffic, it actually goes and does the packet replication and elimination function there, and then forwards packet flow. I don't actually show how it drops and so on, but you can think about if you receive multiple flows from different directions, it will do the lookup and only pass one packet to one direction. Okay. And the replication also you might get the one flow in, but you go out with two flows, or you might come in with the multiple flows in and you go multiple flows out. So the hard issues that we had, so obviously this kind of getting our heads around the replication elimination so that we all were in the same page. So at the beginning, we all were in the same room and in the same book, but not in the same page. So that took quite a while. Mostly it was a terminology issue what we had. So we were talking about the same things, but we were kind of shouting at each other using different terms. And we do realize that it needs a new functionality in a P nodes. Then the other hard issue that we haven't really started too much thinking about, because it doesn't really concern the data plane as such, is like we have this bunch of flow IDs, so there needs to be a way of assigning those in a way that they don't collide. So if you think about, for example, you have in your Detnet network domain, you have multiple ingress routers. So how you make sure that the two ingress routers don't assign the same flow ID for different flows? There's an existing workaround there, for example, from the segment routing, how they plan to do it. And we haven't really taken any opinion on that, except saying that those flow IDs shall not collide. And the open issues, so for the actual data plane itself, we don't see that we would have any open issues. There are a couple of things under work that somehow got pushed, like in the second priority, and that's the service and class of service sections in the document. Also, like we had these overlay labels, L labels, what we call it, whether they are needed in all cases or not, it's not like 100% clear from the document, but that needs to be kind of ironed out. And then this control plane, which is out of scope of this document, but we did consider it to some extent. We know that there will be TLVs and other extensions for LDP and such, but they are different exercise. And for our next steps, of course, we want to kind of continue with this document with the official work.
So we have a few minutes for discussion.
So, Stuart Bryan, so among the data plane issues that you don't have, the first one is that the IP design for pseudowires is radically different from the MPLS design. So if IP is important to you, then you need to study the work that happened. Well, actually, there's two different places. There are a few of the standard pseudowires around TDM that use IP, but most of the pseudowires were based on a protocol called L2TP, which was designed in a different group. L2TP doesn't really have the concept of multi-segment pseudowires. So there's a whole bunch of stuff that you need to look at there. I'm still really worried about how you're going to do the deduplication because depending on the design of the system you've got, it's actually quite hard, as you point out, to do essentially sequence number comparison over multiple interfaces. Well, I don't really know where to go on from there because that.
Yeah. So we discussed this. Yeah. Okay. So we sidetracked the L2TP and we kind of left it to the level that is described in the document in the multi-segment pseudowire document, where is described to some extent.
No, multi-segment pseudowire really doesn't work across an IP network. There is, by the way, in 3985, a sort of fragment of design that Eric Rosen suggested I put in, which was basically carrying MPLS over IP, which is something that actually we should look at in a number of dimensions. But that would allow you to keep a lot of your chips absolutely identical in terms of processing the deterministic network piece.
So we have the assumption that we actually carry the MPLS over IP.
Okay, because that's not the way. I mean, just be careful. I mean, there's a good solution. That is not the way any of the mainstream pseudowires ever got designed or deployed. It was in 3985, but as far as I know, no one ever built it.
Yep. Well, bunch of the pseudowire stuff hasn't been implemented. Quite a bit of the pseudowires haven't been implemented as written?
Well, the
Yep.
NPLS stuff I think is pretty solid. And
Yeah.
there's a huge amount of deployment.
Yeah, I
What
know.
there isn't really is the signal multi-segment pseudo-wire is not a first-class citizen by
Yeah.
a long way.
So I wanted to comment the other thing. So the sequence number comparison over multiple interfaces. So yes, we discussed that quite a bit, how to do that. And it's kind of, at that time we stopped the, if you go for a solution where your interfaces are in separate cards, line cards, for example, and you need to coordinate between those, that's your architecture you chose, so you need to figure it how you do it yourself. But if you have how many of the ports you can put into one line card so that you have a kind of unified thing, that helps.
But it is a significantly difficult problem that we've been looking at for some time. So in order to do packet loss measurement, we have to solve essentially exactly the same sort of problem. And in the end, the only solution that anyone's come up with that's viable is alternate marking. No one has kind of figured out how to do close order packet detection across multiple interfaces on these sorts of speeds with these sorts of precision.
Andy Malice. Like Stuart, I'm also co-chair of the PALS working group. I'm seeing at least 2 drafts that I think you might want to consider bringing into the PALS working group. The first would be the definition of a Detnet pseudowire, including the exit PE behavior for doing the duplicate elimination. The second would be an update to 6071, which is the segmented pseudowire RC, to include the new definition for the SPE and TPE behavior.
Okay, so you want 2 documents to be submitted into
The PALS working group, yes.
okay.
Yeah, so that, I don't know if our AD heard that because she was out of the room. But basically, the PALS co-chair is suggesting that some of this work move to PALS. So we'll have to have some conversations about that.
That's normal operation as you get further down to the details. If there's overlap, right? Well, not overlap, but just work that goes to other groups, we work with them.
Okay, thank you.
Small thing to address Stuart's concern. In our discussions, the people who are doing this kind of packet elimination right now, certainly not in MPLS, the model is that you can concentrate this elimination function at the output port rather than the input port, and you may have multiple copies of it at different output ports. That gives the results that we want. Now, how you implement it is something else, but people are implementing it in that way, not at these data rates, but at the simple algorithms that they're using are certainly applicable to these data rates. I just wanted to mention that.
We are doing well on time. How many people have read this document? That's a reasonable number. With ignoring Andy's comment about which working group that it belongs in, does this working group think this should be adopted in, let's just say, a working group, and if the AD agrees, it'll be this one. If not, that'll be up to the PALS chairs. But how many think that this is a reasonable document to adopt within the working group? Wait, let me.
Okay.
So I can't see behind Andy, and it seems like a reasonable number. And I'll note that the PALS chair is raising his hand, which is confusing me.
Well, yes, no, I wanted to clarify, not all of this goes to the PALS. The relevant parts of this work go into PALS, which would be the definition of the Detnet pseudowire and the changes that are needed to RC 6073, 6071, which is the segmented pseudowire RC. Right? Yes. Yeah.
So an IP, we need a discussion with L2TP working group.
Well, I didn't see L2TP mentioned here.
Right. Okay. So you're going to do it with the version that no one has ever built before, but is kind of an interesting version, which is carrying MPLS pseudowire over IP, which only exists as a side note in RFC 3985. Question mark.
So just, I think this is a good point to point out that adoption of a working group document means that this is a starting point, not an ending point. So, if you're like a silicon vendor and you say, okay, it's adopted as a working group document, so we're going to go implement that, that would be the wrong conclusion to take from adoption. Because, what's that? It's too soon. Things may change radically, even though it will adopt it.
So I didn't know that this had been released out of the design team. As you notice, I corresponded with elements of the design team and expressed via Lower a number of concerns. I certainly would like to read this before passing any view on how consistent this is with the very long-term experience we've had at designing pseudowires.
Sure, and as always, we confirm any decision in the room on the list. And I will point out this was published by the deadline and it's been on the agenda. So there's, if you're looking at what's happening in the working group, you would have seen that it was published. So, but notwithstanding that, you'll have time.
Eric Grayerson. This may be a minor point, but I believe we don't make decisions in this room.
I think I just said that.
No, you said we confirmed the decision made in this room.
There's a subtlety there that's lost on me. As you know, I'm not all that subtle usually. So we're going to move on to the next, which is flow information.
Okay, my name is Balázs Varga. I will present this draft to you, which is about the flow information model for Detnet, and it is based on the work done in IEEE in the TSM work group. So the two co-authors are János Farkas, who is the chair of the TSM work group in IEEE, and Rodney Cummings, who is the editor of the 802.1 QCC draft or document. In this presentation, you will see the goal of this draft. We will go through the in detail on the content of what is there in the draft, and we have also prepared some proposed next steps regarding this document. For the discussion and for the presentation, we have selected a figure from the data plane solution draft, which is about where you are interconnecting to TSN end system over the Detnet network. And with colors, we have highlighted for which elements we have information groups in the draft. So it is about the source, the destination, and the flow between this between these two end systems. So the draft describes the flow information model for Detnet based on the TSM work done in the 802.1 QCC document. It defines the flow information model for both layer 3 and layer 2 flows. There are many models in the QCC draft, and we have selected the centralized network distributed user model, because this is where you have a UNI between the end systems and the network, and you have a format of centralized network control in the transport part of the network. However, we think that there are also some other models in the QCC which might be interesting for the Detnet work group, especially if you think about industrial machine-to-machine use cases, because for that, fully centralized model can be also an approach to describe the flow information model. We have also some non-goals in the document, so we do not intend to specify a flow data model or a Detnet configuration in this document. This is part of the QCC draft, and we think that this is something interesting, but in this current version, we do not have that piece of information in the draft. So we will go through the technical content of the draft one by one. So let's start with the end systems. So we have three groups of information which are needed in the flow information model. One is related to the source. It will describe the source characteristics. And this is an information group which is applied from the end system towards the network. The other information group is related to the destination. And of course, it is describing the destination. And this is also an information group which is provided or applied from the user towards the network. The third group of information is related to the Detnet flow and about its status. And this is practically informing the end system whether that flow is ready for use or not, or what is the status of that flow in the network. And this information group is applied from the network towards the end systems. For each flow, we can define two types of operation, a join and a leave operation, where a source or a destination can join or leave a given flow. We have added a note in the current document that we may consider to introduce a third operation, which is a modify. This means that if you would like to address scenarios where the flow is slightly changing, like the max packets per interval parameter is changed during the communication. So we have formulated the two questions, whether we should have the modify operation, and if yes, then what parameters should be possible to change under this modify operation. Section 6 is dealing with the flow attributes. So we have a data flow specification attribute which describe the parameters of a layer 3 and a layer 2 Detnet flow. So these are the attributes you can consider in order to recognize that flow. The traffic specification attributes, they are describing the traffic which is sent by the source towards the network. It has three parameters, three attributes, an interval. This is the period of time in which the traffic specification cannot be exceeded. And we have a max packets per interval, so how many packets can be transmitted during that interval, and the maximum payload size, so what is the size of the packets the source is transmitting. And of course, from that you can calculate the load on the Detnet network. We have a third flow attribute, which is called flow rank. And this is practically providing a rank of a given flow relative to the other flows in the network. So if you have a resource shortage in your network, using this Boolean type of attribute, you can decide which flows should be there in the network and which you should temporarily purge from your network. Okay, let's look now to the source attributes. The source objects specify the behavior of the source for the flow, so how and when the source is transmitting, the requirements that the source has from the network, and also the capabilities of the interfaces of the source. So here on the right side, we have listed the attributes which are describing the source in more detail. And for each operation, the join and the leave, some of those parameters are mandatory and some are optional. We have a very similar list for the destination. Of course, the traffic specification and flow rank, this is specified by the source. So this is what you don't have for the destination. And here again, we have listed regarding the operation, what attributes are mandatory and which are optional for a join operation or for a leave operation. There are some common attributes for the sources and the destinations. This is what is highlighted in chapter 9 in the document. It is about the end system interfaces, which is a list of IDs for the interfaces which are used by the source and the destination in order to receive or transmit traffic towards the network. Interface capabilities, this is something that we think is still to be defined. This is where you can define some encapsulation capabilities of the interfaces, whether that interface is supporting in the source or in the destination, the frame replication and elimination and so on. But we think that this is something to be discussed a little bit further, and the QCC draft is very layer 2 specific in that sense. So this is something have to be extended. And the third group of common attributes is the user to network requirements. So this is practically the service SLA, which is required for the flow. And this is where you can define latency and reliability related requirements towards the network. Last but not least, the information group is what we need is regarding the flow status. And this is an object which is provided for the end systems from the network in order to highlight the status of the flow. This object is unique for each end system because some of the parameters which are there, they are unique, like maximum latency or accumulated latency. This is something that is specific for the end system. And here we have listed the mandatory and the optional attributes which should be there in this status object. So data flow specifications, so which flow we are speaking about, some status info. This can include the source and the destination status. It can also include some failure codes if there is any failure related to the flow. Accumulated latency, which is also a unique number depending where your destination is in the network. Practically that's it, what we have in the current version of the draft. So we think it is just a early part in order to discuss the flow information model related attributes. So we need some discussion whether anything is missing from the draft regarding those. And also some of the format of the attributes should be discussed a little bit more in detail. Like, for example, in traffic specification, whether those 3 parameters are enough for us in Detnet in order to describe the flows. And based on that, we first intend to update the draft and came back to the next IETF meeting with the updated version of the draft based on the feedbacks.
We have a few minutes for discussion. Any comments?
Hi, I'm Kiran from Huawei.
I'm sorry, can you lean in a little bit? I can't hear you.
Kiran from Huawei. I'm not too familiar with Detnet, but just curious that are you looking at flows for IoT which do not include L2 and L3 addresses, IP addresses or MAC addresses?
This is not done in the current format, so still to be discussed.
Any other questions? You didn't say it explicitly. I think you implied it though. That what about alignment between what you have in your draft and what's going on in the data plane draft?
The thing is-
Notably for flow identification, for example.
Yeah, it is not yet there, the flow ID that we have defined in the data plane solution. So this is something to be added. But this work was parallel, so we don't want it to add it in the first version of the document.
So you think you would try to do that in the next one?
Yes.
It would be particularly interesting in what you do for pseudo wires over IP in the current form or whatever form we evolve, because that's going to be an interesting discussion. Because to some degree, the assigning resources to flows that are MPLS encapsulated is a well-worn path. Doing it for IP, certainly for COS, it's well understood, but for QoS, there's been some attempts that haven't worked very well. So it'll be interesting to see what you come up with.
Yeah, this is also something regarding QoS. We have also some part in the service model draft, which is not yet selected to which draft it should be moved, but this is something to be discussed.
It's Yuan from Huawei. I will read your job. Certainly you have described it both from the UI perspective and also from the end-to-end perspective. I just wonder maybe you can also consider some performance parameters in the job. I have the flow loss of a packet or jitter something.
Sorry, would you repeat the question?
I mean, maybe you can also consider some performance metric in the job.
So you are asking about the performance metric end-to-end regarding the flows.
Yeah.
So it is in the user-to-network requirements where the latency and the reliability related parameters can be defined.
Yeah.
This is something that might be worth for some further discussion because, for example, this reliability related parameter, which is number of replicated trees, which means the maximum number of disjoint trees in the network. Maybe this is something that we would like to do differently in layer 3 and not defined by the end system, that parameters. They would like to say something about the reliability requirement, and that is something that is transformed by the network to find out whether frame replication and elimination or other methods should be used in the Detnet network in order to provide that parameter end-to-end.
I think that one field is the requirement from the service. And another field is what the transport network can provide. Two different things.
Sorry, I have not got.
I mean, it's a service requirement. Even when the network is not ready, you have some requirement from the service. But what's the maximum latency can be the service needed. But in reality, when the network is providing the transport of the service, I think what's the guaranteed, what's the real performance for the network? I think that's not a thing.
So if the requirements which are needed for the service to be set up is not possible to provide in the network, then in the status object, you have a status info where you can highlight some failure stuff. For example, the endpoint asks for frame replication and elimination, but it is not possible to support by the network with that number of disjoint paths. This is something that with the failure code you can reflect to the end systems, if that was what you have asked for. Okay.
another, we have another contribution in on the flow information model. So maybe we work together to see what's the meeting, what is still needed to develop. We can.
Are you saying you have another
outline.
document?
Yeah.
This is the one from
Right.
last time.
Sorry?
There was a, is this the same document from last meeting? Is that what you're referring
Yeah,
to?
yeah. We've been present at the last meeting.
Right. So there was another flow information document, so it'd be good if the authors get together and figure out how to bring them together.
Yeah, I see some differences regarding that. For example, the specification of the flow characteristics. This is something that is defined with burst-related parameters and that model. And it makes some ATM-related references towards what type of traffic is sent towards the network. So I think this is something to be discussed. In this flow information model, we have taken the results from the IEEE work. And this is why we have defined it in that way, which we think is more appropriate for some industrial use cases. But I think this is something to be sorted out and discussed further.
Actually, we are thinking from different perspectives.
Yeah.
We can discuss it later.
Yeah, absolutely.
So hopefully you can take advantage of being here this week and have some good conversations. If you end up finding that you've come to some conclusion, send it to the list. If you find that you need more discussion, then go into email. No reason not to have that on the list if you're willing.
Yes.
Okay, thank you. So I think we're moving on to security. I think we only have the PDF for this, if I'm not mistaken. Is that right? PDF is fine. Just takes me a second to readjust.
Okay, so my name is Tal Mizrahi. I'm from Marvell. And this draft was written by a team of security enthusiasts led by Ethan Grossman, and also including Andrew Hacker, Sabir Das, and John Dowdle. Next, please.
It's in your hand.
Oh. Can't beat the old habit. Okay. So this is basically the outline of the draft. It starts with a background, and then the main part of the draft is about security considerations. And when we say security considerations, it consists of three parts: threats, impact, and mitigations. So by threats, we mean how can an attacker attack the system? And by impact, we mean what happens if there's a successful security attack? And mitigations mean what can we do in order to either prevent or mitigate some of these attacks? Now, in the current draft, which is basically still preliminary, we have the first part, which is security threats. We've started with that. Impact and mitigations will be added in later versions of the draft. And finally, the third part at the bottom here is a collection of security-related statements. Basically, the idea here was to include in one place in this draft all the different statements from different Detnet-related drafts about security. So these statements are simply quoted here, and they will be used as a baseline for writing the text of the rest of the document. Okay, a little bit of background, and basically the main question we need to ask ourselves in this context is what is different about deterministic networks in terms of security, which is not there in conventional networks. So first of all, deterministic networks have been around for a few years, but are typically deployed or have been deployed so far in local area networks in relatively restricted physical geographic locations in isolated networks. These are by nature easier to secure. And the main purpose of this working group is to evolve to move these networks or to be able to use deterministic networks over WAN connections over wide areas. And obviously, this is more challenging in terms of security. Another interesting aspect of Detnet is the fact that the network controls physical devices, such as power grids or industrial controls. So at the end of the day, if a security attack compromises some of the network equipment, it doesn't only compromise the network equipment, it also compromises some physical equipment, which may have other implications like mission critical or safety critical implications. And also we have to keep in mind that we're talking about a converged network, which means there's non-Detnet traffic, there's Detnet traffic, there's also control plane and signaling traffic. All of these are sent over the same infrastructure. So basically, these are the challenges we're talking about. And when we ask ourselves what is different between a Detnet and the conventional networks, these are the challenges in terms of security. So let's talk about the security threats. This is currently the main part of the document. And before we talk about security threats, we have to talk about attacker taxonomy. So basically, on the left side of the slide, we distinguish between internal and external attackers. And the idea is that we assume that a Detnet flow is sent from a source to a destination, and both the source and the destination reside in a trusted zone, in a trusted part of the network. And in between, there's a part of the network which is not trusted, for example, a provider network. An external attacker is someone who is not within the premises of the trusted network. An internal attacker, on the other hand, is someone who either has physical access to the trusted part of the network or is not geographically inside the trusted network, but, for example, if the traffic is encrypted over the provider network, an attacker who has access to those cryptographic keys is an example of an internal attacker who doesn't have to be physically inside the trusted network, but is equivalent to someone who is inside the trusted network. On the right side of the slide, we see the distinction between on-path and off-path attackers. So basically, an attacker who is on the path between the source and the destination is called a man-in-the-middle attacker. An attacker who is not on the path is unable to modify the traffic or to intercept it, can only inject traffic. So we call this kind of attacker an injector. Okay, now we're going to talk briefly about each of the about some of the threats and what each of them means. And we encourage you to read the draft and to read more details about this. So first, and probably one of the most interesting attacks in the context of Detnet is the delay attack. Basically, an attacker can simply delay the traffic in a way that is selective, so adding different delays to different packets. And that means that even if you have the strongest cryptographic mechanisms, the attacker can still disrupt the Detnet service by simply delaying the packets. So that's one attack. The second attack here is by trying to manipulate the Detnet flow identification mechanisms. Okay, so an attacker by modifying the packet headers or by spoofing packets, the attacker can manipulate some of the equipment to believe the traffic from the attacker is a legitimate Detnet flow. In this way, the attacker can consume some of the resources which are dedicated to that legitimate Detnet flow. And the third attack is an inter-segment attack. And the idea is that if the network is segmented or sliced between different parts and each part of the network has its own resources, in this attack, the attacker can transmit traffic in its own segment and this way affect the performance of other segments. Okay, another aspect is replication. So in Detnet, we use replication. Basically, there's a source which replicates packets and sends them over multiple paths. And then there is a termination point which receives the multiple packets, and based on a replication header needs to choose which replica to receive and which one to eliminate. So an attacker can try to attack the replication mechanism. So first of all, we have to notice that by replicating, that means we use multiple paths, and by definition, that means that we increase the attack surface. That means that potentially there are more points in the network that can potentially be attacked. So that's one aspect. Another aspect, the second bullet here, is the attacker can basically try to manipulate the replication header. So we're assuming there's a replication header which includes information like a sequence number, which is used by that termination point to choose which replica needs to be forwarded. So the attacker can manipulate this replication header in a way that either causes the terminating point to receive both replicas of the same packet, or to eliminate both replicas, or the attacker can do even more than that. The attacker can hijack the flow, that is, to cause all the packets from the attacker's path to be received and all the packets from the other paths to be eliminated. So these are replication related attacks. Now, there are also attacks related to paths, to path selection. And there are two attacks that are described here. Basically, the attacker can manipulate the control plane, for example, spoof control plane messages in a way that affects which paths in the network are used, or in a way that just increases the attack surface. Okay, again, this way the attacker can cause more points to be potentially exposed to other attacks. So we talked about attacking the control plane. More generally, the control plane can either be attacked by modifying existing control plane packets or by injecting new control plane packets. So these are two types of attacks. Recon. So by passively eavesdropping to the network, an attacker can gain information about which Detnet flows exist, their bandwidth, information about their schedules, their shaping, and so on. So this is the recon attack. And finally, time synchronization is one of the things that Detnet relies on. So by attacking the time synchronization mechanism, the attacker can actually disrupt or compromise the Detnet service itself. So there's a table which is copied and pasted from the draft and kind of summarizes the threats. Again, go ahead and read the draft and feel free to send us any comments about that. So we submitted the first draft at the beginning of March, and we are looking for feedback from the working group. We're planning to add some more parts. Like I said earlier, we're planning to add the impact and mitigations, which are currently not yet there. And naturally, we'll be asking for working group adoption after that. Yes.
Yeah, Norm Finn. Well, wait, that was, I was really impressed with your first draft. Thank you.
Thanks.
A minor comment. One of the few ways in which Detnet does reduce the attack surface, perhaps, is that because of the extensive, part of this you mentioned, because of the extensive protections it tries to put in so that a misbehaving flow can't disrupt properly behaving flows. to limit the damage caused when something does fail, things do fail. And which leads to a side note, which is it's very difficult to tell the difference between ordinary failures and misbehaving nodes and malicious attacks. But because of the protection it puts in there, it's very hard to do a simple DOS attack. Very, very hard to do a simple denial of service in a deterministic network because of those protections.
Thanks.
Right. So I'm rather curious as to whether you've any idea whether these problems are tractable or not, because I know that the timing world has spent quite a lot of time trying to understand how to protect itself against attacks. It's got something that you haven't got, which is that time is time is time, and so it can look at multiple sources. But I'm not really aware of of decent solutions to problems where essentially the dynamics are what you're trying to protect, as opposed to the contents of the data.
Yeah, so the way I see it,
Apart from the eggshell model, where you stop anything bad getting in at the edges and just make sure everything's protected from physical intrusion.
the way I see it, we're currently looking at threats, and we will be looking at solutions or requirements later on. So we're not at the point yet of saying we need this security mechanism or that one.
A quick comment. Defense in depth, thy name is Detnet. Partly because if you can do anything with the time security, and that's basically just lots of different paths to deliver the time and lots of sources of time and so on. If you do have a handle on that, we do have the advantage of having time so that we know when things are supposed to happen and when things are not supposed to happen. And because of the, we go to a lot of trouble to, if you give me a packet, it must be the right packet, and it must be on the right interface, and it must be at the right time. Otherwise, you're misbehaving, and I don't trust you in this network to be running whatever machinery you're supposed to be running. And I can't trust the information you're giving to run the machinery I'm running. So if you're not giving me the right packet at the right time, I'm probably going to discard it and shut down that little bit of operation. And the downside is you get a lot of false positive. Well, yes and no, because presumably there's two of him, one over there and one over there, trying to give you the information. Okay? So just to protect yourself against ordinary malfunctions, he went crazy, somebody downloaded the wrong software in there and so on, and he's doing the wrong thing. You know, that's the sort of thing you do. Okay? So yes, it's a disadvantage, but it's also an advantage, and of course, the real attack then becomes actually attacking your models for what is proper operation, which fortunately tends to be a straightforward kind of encryption kind of problem that we've been doing all along. So,
Of course, the people who've been shift right again, the people who've been thinking about this problem most are the TikTok and NTP groups.
Right.
But as I say, I think they have a problem that's orders of magnitude easier, just because they're only trying to get exactly the same thing, and they have a local reference for the time to help them out. But
Yeah.
that are a group that you probably should engage with.
Mike, there's people remote, please. Microphone, there's people who are remote.
tremendous amount of work on this in the automotive industry, most of which we don't have access to.
Okay, thanks.
Right, but the IEEE also has been doing some good work in this area, and we do have access to that. So even though your next step was to do an update and then look for working group adoption, sort of in recognition of how good and important this document is, we're thinking we'll do something a little different and ask support in the room now for working group adoption. So usually authors ask repeatedly. First of all, let me ask, is there any reason you wouldn't want to adopt sooner?
Not that I can think of.
Okay. Right. How many people think that having this type of work is important for the working group? Everyone's hand should go up now. Okay. So it's certainly a good number. How many people have read this document? It's a reasonable number biased towards the front of the room, which is okay. How many think that the document is mature enough to be adopted as a starting point for the working group? Not a lot. So I think that the folks in the room at least agree with your assessment of do one more version and then talk about adoption. Okay, great, thank you. So we're going to move on now to Norm. Just give it a second.
Hi, Norm Finn of Huawei. This is a fairly quick presentation. I wanted to talk about the connection between Detnet and 802 time-sensitive networking, at least one of those connections. Now, we've tended to focus in the DP-Alt group on the multipath redundancy, but the other part of this is reserving resources so that you have bounded end-to-end latency and zero congestion loss, which is, those two things are the thing that actually got this whole thing kicked off and generated the interest for industry and for audio, video, and so on for this whole thing, because that's what makes it real time, is bounded end-to-end latency. It's not, now these are lessons from deployed TSN networks. This stuff has been deployed for a while now, and people are using this stuff. And I wanted to point out some things. One is that achieving zero congestion loss and bounded latency is a very different problem from low average congestion loss and low end-to-end latency. Okay? Those are different problems. And the details of the way in which you drain your queues at every hop become really important, because any variation in your, any irregularities in your queue draining algorithm result in additional buffer requirements at the next hop. And those add up very quickly. The algorithms that are used to compute the latency bounds, at some point the customer says, I want this flow to go from here to there, and it has to, I need it to get end-to-end latency has to be at least this good, this many microseconds, this many milliseconds. The network needs to compute, well, can I deliver that or not? And if I can, I'll say yes, and if not, I'll say no. So whether that is a central control algorithm or whether that's a peer-to-peer algorithm that runs through the network, they have to know exactly how the queues work in order to determine whether that's possible or not. Okay? As a general thing. So my impression from Lou and from others is that IETF typically doesn't go into detailed mechanisms of how you drain queues in great detail. But we need to have those, we need to go into that detail to make this work. Now, we've looked at least 5 different queuing mechanisms in 802.1 now, standardized several of them. Why in the world would we do that? It turns out that different queuing mechanisms have different properties, and there are a lot of trade-offs for a lot of different properties. Obvious ones are implementation complexity and therefore cost to implement. But there are a lot of other things of how many flows you can handle. is there a minimum bandwidth contract as well as a maximum bandwidth, and what kind of ratio can you get between those? Does the network topology affect the hop-by-hop contribution of latency, and so on? All these things, and different use cases wind up wanting different points in this trade-off space. So, I think it's a good idea if the Detnet routers and label switches take advantage of the TSN queues. In the first place, most of the existing TSN bridges are also routers and do this already. The second thing is that if you look at delivering data on time, delivering data with a certain bounded latency, it really doesn't matter at every hop whether you're incrementing a TTL or whether you're swapping a label or whether you're bridging straight across or adding a VLAN tag. All that really matters is how many wires does it go across and how often does it have to sit in a queue waiting for its chance to go. Because in your box, whether it's a router, label switch, bridge, or all of the above and more, you generally wind up going to an Ethernet interface and having a bunch of packets queued up to go out. And it really doesn't matter whether they went through the bridging function or the routing function or the label switching function or anything else. They're sitting there in these queues trying to get out. And that is most of what controls the end-to-end latency, is how long you spend in these queues and how many queues are there and how many buffers there are. So it really doesn't matter whether it's a router or anything else. Now, right now, there's a problem for Detnet in making normative references to the definitions of these queues, which is that they are buried in an 1,800-page monster document, which is all about bridges. Okay? Different kinds of bridges, big bridges, little bridges, provider, Ethernet bridges, and so on. And all these definitions of queues are tied up intimately. For example, the MIBs that control them and the Yang models that control them tie them to bridge ports with a bunch of other parameters that are tied up with bridge ports, which are irrelevant to what we want to do here. And all the managed objects are tied to the bridge MIB and the bridge Yang models. So even if you go to implement these queues, you're going, if you tell an engineer, I want you to implement these queues, they have to look at that big .1 queue, and that's not terribly helpful. And is it okay if I finish this slide and then go to the questions? Okay, good. So I would suggest that we and Detnet and TSN cooperate somehow to generate a Yang model for queuing that applies equally well to a route, bridge, or label switch. In other words, it describes, this is how I want to configure my queues. This is how many queues I want. These are the queue training algorithms I want. This is the hierarchy. This is how the queues go together on this physical port. Okay? Now, you'll notice I haven't talked about input queues. I haven't talked about, is it virtual output queues and so on. There's plenty to talk about, but it ties to an interface. And if that interface is a bridge port, if that's a router port, or if that's a label switch port, that's fine. The important thing is that it's tied to something that queues up, that lets the packets go out onto that wire. That Yang model that can be used to supply the knobs that are tweaked by our reservation protocols, by our central controller, or whatever. This provides a way of a language whereby our drafts can talk about parameters that might, additional parameters that might have to be carried in some peer-to-peer protocol that we do here that gets related to these queuing parameters, because ultimately the reservation protocol has to be tied to parameters on the queues. Okay, and this Yang model would be the language for doing this, and it would be our interface so that we can tie what we're doing here, especially in control protocols going forward, to the physical world.
Eric Gray Erickson. Back on slide 5, you had the first bullet there. I just want to add something to that. Because just reading that bullet, it kind of looks like, well, we're all done. What are we doing here? In fact, the application I think Junie talked about, where you're talking about bridging TSN islands, what you're saying there is essentially true, but it doesn't really help you with the end-to-end solution. The reason why that's true is that when you talk about router interfaces that support TSN, that means that you have an Ethernet interface on a router that's actually capable of doing TSN across the Ethernet link.
Correct.
And not that it's actually capable of doing TSN to TSN to TSN to TSN.
Sure.
So that's the complication. So where you have a router that actually supports the TSN islands interconnection, you need to have a sort of standard approach, both models and however you're managing it or configuring it or signaling or whatever, that allows you to actually do that at the next hop as well. So I just wanted to add that. Thank you.
Yeah. Yeah. And this isn't all the Yang models we need. We brought that up earlier. There are certainly more Yang models we need, but this is one. And the implication here is that we let 802 go ahead and define these queuing models, and we'll just take advantage of them. Okay? There, of course, has been work done on queuing in IETF. How does this fit? I don't know. I'd welcome suggestions.
So if you remember the slides during the intro part and working group status, one of the things we had identified as on our milestones, but that we don't have any documents on yet, were Yang models. So you have a proposal, let's go back one. You have a proposal where you're talking about, who was that slide? Yeah, there you go. Yang models, or a Yang model. That is perfectly within our scope, and as long as it's consistent with the other work, that's great. So this isn't a stretch for us to be thinking about. So that's great. A couple of times, both in this talk and an earlier one, there was a mention about us doing control plane extensions. I'd like to point out that that is outside the scope of our charter. The Yang piece is completely in scope. Making sure what we do from a design standpoint is supportable by existing control planes, that's also great. But actually doing control plane extensions, we'll talk about that once we've delivered on everything else that we're supposed to do, and we're thinking about whether to shut down or do something else, then we can talk about it. Until then, we're not going to do control plane extensions in here.
Is it
Name,
acceptable, George Swallow, is it acceptable to work on requirements for control plane extensions?
So when we wrote the charter, we envisioned that that would be done indirectly by having a good flow information model and then good Yang models, which would control Detnet flows. And so that if someone wanted to go do the control plane work, they would see, okay, here are the parameters we want to go automate, because we would have that all defined there. So indirectly, we thought we covered that in the charter. If you want to do a direct document, I would look to our AD to comment, because we're splitting hairs almost.
Okay.
Do you have a document you're thinking of?
My only thought is that this stuff is pretty complicated if you want it to come out right. Either send the document or, even better, send people.
Speaking as your AD, if we didn't envision this, I think we're just getting started on it. So as we go into the details, then we can coordinate with whichever groups are appropriate.
Okay, thank you.
I think that I like the suggestions of discussing some of the requirements for the control plane. I think Yoni mentioned about that they have already discussed about some of the control plane things in the data plane design group, but it would be good to actually have a document even it's an informal document, I think it should.
At this stage, we really should be focusing our energy on our primary and core deliverables. And, you know, if along the way we happen to note things in our documents, that's great. I wouldn't, if we start spending too much time focusing on control plane now, we will not succeed in delivering on the things we're chartered to do.
So my comments have nothing to do with your work plan. This is just, if you want that kind of thing to happen, we would, speaking as MPS chair, would like a somewhat, there be some consensus behind whatever comes in, be it either individuals or some document at some level of, you know, formality. But that we not start using other work groups to argue among debt people.
Sure. I agree with that point, where we don't want to start having Detnet control plane arguments before we figured out other parts in this working group. So as always, we're contribution driven. So if you think you have something that's important for the working group, please bring it in. Just please don't bring in an LDP extension right now.
Bringing this back to what I was talking about, when I say cooperate somehow, I will mention IEEE is now doing Yang models on GitHub. We've got our point on GitHub. Anyone can get at them and see what's going on, contribute, whatever. That might be a good place to start this. I don't know. I know there's interest in IEEE in doing this, and I know there's interest here. And I'm not sure whether the first thing here would be working on models, whether the first thing would be a draft, whether the first thing would be a project in IEEE. That's something I'd like the interested parties to work about, to talk about, because I think there are, both groups have a stake in making this right, and I think different parts of the expertise may be in different places. So it's going to be, I think, a fun exercise to figure out how to do this.
Okay, with that, we're actually a few minutes ahead, and we're going to move to the last presentation, which is on backhaul networks.
Okay.
Just, that's not the right thing. Sorry. I failed. One sec.
Okay. Good morning, everyone. I'm Lun Shao from Chongqing University of Post and Telecommunications of China, and my presentation is about a bachelor network. Here, the motivation and the background. First is here are some descriptions. First is the introduction. Backhaul networks is a transition network which combines the introduction, field network, and the higher level networks, and to reach the goal of interconnection. And then is IPv6 technology, and the WPAT standard is one of the three international industrial wireless standards, and then is a software-defined network. The goal is to provide a field network and a backhaul network about the joint schedule method, and to enable the end-to-end joint schedule of the cross-network data streams, and to recognizing of the different types, and to bandwidth guarantee specific to different types of
network entering date. So first, it's about the joint schedule architecture. This is a typical deterministic industrial networks and the backhaul networks structure. In this structure, the loads deployed in one plant can communicate with the loads in other plants by the backhaul networks. And there are many controllers in network which together constitute the control plane for the whole industrial network. At present, there is no unified standard for joint architecture in industrial, and there are two main frameworks. One is the distributed architecture, and the other is the centralized architecture. Here's the distributed architecture, also called the east to west architecture. So in this architecture, the status of all the network controller is equal, and the controllers are connected with each other to form an I-structured network. In practical application, the architecture not only need to extend the east to west interface, but also to maintain a global network topology in controller. Only each controller maintain a global network top, it can ensure the deterministic control. So this is the centralized architecture, also called the vertical multi-level architecture. The control plane is divided into two parts. One is the basic controller, and the other is main controllers. So for deterministic network, the scale of the network is not very large, and a single SDN controller is sufficient to meet the demands of industrial backhaul network. If the central architecture was applied into the industrial network, it can may cause minimize information interaction and waste the network resource. So here we take the VPAR as an example and propose the joint schedule architecture. The control plane comprised VPAR with system manager and SDN controller. The joint schedule is integrated to the SDN controller in the form of plugin. And the VPAR managers receive the joint schedule by establishing a connection to the SDN controller. And the joint schedule achieves the determined control for the entire network by directly calling the corresponding modules of SDN controller. And in joint schedule architecture, the deterministic network and the estimate-based network are joint scheduling. The controller and the schedule for the entire network can be realized by joint schedule so as to provide a real-time protection for each data stream. And there are some requirements about the joint scheduling. First is the determinacy. The data of industrial field network, backhaul network, directly relate to the monitoring and the control of the industrial production. Time synchronization. The industrial field and the backhaul network is converged network and meets some schedule modeling to ensure the determined data stream. So it requires high time synchronization accuracy and the compatibility. Some mechanisms interface and will be necessary when conducting joint scheduling to be compatibility with the industrial field and the backhaul network. And last is snappability. When it comes to cross-domain or cross-network, data scalability should be ensured during joint schedule process. Uh, and this is a joint schedule method in which the communication entities comprise a joint schedule controller and the WAPA network managers, gateways, and the field devices. The joint schedule consists of a SDN controller and the joint scheduling plugin. And WAPA networks are unified, managed by the joint controller. The joint controller assigns a network identifier to each network manager and for identify different tabs, network tabs. Here are some detailed steps to establish the backhaul networks, including 8 steps. And this is the access of network managers. Step 1, the network manager will establish a connection with the joint controller, and then the joint controller assign one party to the WAPA network and establish a mapping relation. Step 3, the joint schedule will send the request for getting topology information and some information of the network. Step 4, the network manager will reply with the topology information and network information. And last, the joint controller will send a configuration completion to earn the price. Here, in this joint schedule process, the path deployment and the resource allocation for WAPA network are performed by calling the WAPA network system manager API interface. So the system manager will query the corresponding information of failed device in the network and then return the received information. And system managers configure the communication resource for their corresponding gateway device, routing equipment, and field equipment. Finally, will send a successful reply to the related schedule after receiving a successful response. Unless the gateway protocol conversion, including 4 tabs. First, after receiving a data packet and join whether the data packet is managed data. If so, forwarding the data packet to network manager. Otherwise, we're looking up to VCR. After uploading the VCR, it will look up to IPv6 address according to the root ID by the gateway. And finally, encapsulate the WAPA data package in IPv6 format by gateway. So this is the bandwidth guarantee of the IPv6 backhaul network. I also include the 4 steps. First is to calculate the path information and the network resource, and then verify whether a bandwidth in the path is sufficient to meet the demands. If so, you will deploy a float table to SDN controller, or otherwise it will recalculating the path information and the resource assignment and selecting the secondary path. So,
Sorry, we lost the race. My laptop decided to stay on over lunch and do a software update, so the battery was a little short.
Can we take a question while you're
okay.
The WAPA and ISA 100.11a and wireless HARP are the 3 process control networks which do this sort of operation, and they are roughly equivalent for the purpose of what this working group is interested in. And we have very little information here at the IETF about any of those 3 standards. But we have 6-dish, which is, again, roughly equivalent and doing roughly the same things. And so I'm concerned that this document focuses a lot on the WAPA. I suppose to take it a more abstract view of a network like a 6-dish network, or a variation of it, which this is, and just be more agnostic to the exact standard that is on the wireless system. So my recommendation would be take WAPI as one of those 3 examples. What you're describing works for all 3, actually works for 6-dish. And because 6-dish is better understood in this room and in the IETF, mention 6-dish primarily and the other one as other examples.
Thank you. Thank you. I haven't considered it very deeply before. Yes, thank you. Thank you. So last, the industrial backhaul network can regard as a black box, so that we can ignore delay impacts and so that we can consider delayed impacts and ignore its internal details. When the data stream comes out in the backhaul networks, if the Detnet is missed, then it indicates that the data have gone through a poor network and it needs to be retransmitted, or otherwise there is enough time left. And then we can ignore the delay of industrial backhaul networks and build some models of the network. Thank you.
Questions? So one thing to keep in mind is we're not doing control plane yet in the working group.
Control plane?
We're not doing control plane yet.
Doing data plane.
Only data plane right now. And also the interface to a control plane through Yang. That we're supporting now. There are other groups doing this type of control, notably the T's working group and in the what's called the ACTN effort, but that effort seems to be well aligned with what you're talking about. So you might want to look at that and see if you could tie that together. It might be worth looking at.
Oh, thank you.
At the stage we're at, would this be of interest as an additional section in the usage?
So we actually specifically talked to Ethan about that, and what he said and convinced us of, I don't know if you want to go up, was that it's this isn't really a new use case. It's a new way of implementing existing use cases. So you could implement a few of the use cases that are already there using this type of approach. So that doesn't belong in a use case document. That's more like in a control plane architecture document or a control plane framework document. At least that's what Ethan said, and we bought it. He's in the room, so he can defend himself.
Eric Ray Erickson. I didn't get that out of this presentation at all. I got this as roughly talking about factory automation with centralized control. That's a use case.
And we have that use case.
Right. So, I mean, this doesn't even seem to indicate to me any particular way to implement that use case.
Okay.
We just seem to be talking about it in general.
You know, when we talk about controllers and hierarchical control, that to me says
That's a way of
a way of implementing a use case.
Okay.
And there's a lot of that in the document. Well, I think we have managed to complete our agenda. We have 5 minutes left. So unless someone has anything else to bring up the mic, we'll give you 5 minutes back in your life. We look forward to seeing you at the next IETF. Amazing, it's only Monday. We're talking about Prague, but we'll see you then. Thank you all for participating. one of these days I'll get this thing, so it's charged right for the whole day. So the reverse happens, we eat that in the morning, because over lunch you can suspend that. I have to just shut it down. So we have an active clock.